For squads of soldiers holding an offensive line or probing the enemy's line, firing $1 million missile to take out a small drone is just not a practical solution. So the Army has been busy testing out more realistic ways to keep soldiers safe, and they're calling it Project Flytrap. Defense companies, both large and small, and Pentagon leaders have been busy building new microwave weapons, cheaper missiles, and other large solutions. But at the squad level, those guys are still pretty vulnerable. Flytrap started as a soldier-led innovation project inside of the Army's Rapid Capabilities and Critical Technologies Office, or RCCTO, instead of developing one new fancy expensive silver bullet weapon like the Pentagon is wont to do. Flytrap combines a variety of tools, many of them commercial or non-program, into a modular anti-drone tool. It is being designed with lessons from primarily Ukraine in mind. Years of watching cheap ultra-maneuverable drones behave like guided missiles as they take out entire dugouts and main battle tanks has forced planters to face a hard truth. You can't just shoot one of them down and think the problem is solved. These drones typically work in teams, with sometimes dozens waiting for the opportunity to strike from all angles. Now we're even seeing that some are being left on the ground as part of a lurk and strike tactic. To stand any chance against this onslaught, you need a layered defense. That includes radar jamming and electronic warfare, kinetic interceptors, and fast decision-making tools. Getting all this put together is not a simple thing. So with the latest version of Flytrap 4.0, they field-tested it as part of Defender Europe 25, which is a NATO exercise in Poland. And this time it involved US and British soldiers. Defender Europe 25 is one of the largest NATO exercises of the point of Flytrap 4.0 wasn't just to see if the gear worked. It was also to see if soldiers with minimal prep could use it effectively in a real-world scenario. After all, simple solutions really aren't simple if they take weeks of training to use. Effectively, the primary testing units fell under U.S. Army, Europe, and Africa Command, and belonged largely to the 3rd Infantry Division. These soldiers were responsible for integrating Project Flytrap across rotational forces and serving as the operational test bed in theater. The British Army 7th Light Mechanized Brigade Combat Team, known for its expeditionary focus and rapid reaction capabilities, also took part. This unit worked alongside U.S. elements to test interoperability and layer defense tactics. U.S. Army's Future Command and the Rapid Capabilities and Critical Technologies Office, the RCTTO that we already mentioned, were also there, and both were involved in system selection, capturing that sweet data and coordination. And lastly, the Joint Counter Small Unmanned Aircraft Systems Office, or for short JCO because that makes perfect sense, was also there. They oversee the doctrinal and technical validation for counter-drone integration across the services. These groups and soldiers conducted drills that simulated actual battlefield conditions, including drone swarm attacks with multiple simultaneous threats from all different directions. And altitudes pop up. FPV attacks replicating what troops have faced in Ukraine, using small quadcopters for kamikaze strikes, GPS, jamming, and denial environments where some radar and command and control systems were limited or degraded. And payload diversity, including simulated ISR platforms, which again are intelligence surveillance and reconnaissance platforms. Munitions-bearing drones. And decoys. The goal was to stress the full spectrum of defense from early detection to final defeat, using gear that troops had to learn, adapt to, and operate under pressure. Each engagement was designed to require rapid decision-making, forcing troops to determine if it's best to jam the drone, intercept it with something like another drone, or take the shot from a shotgun or a rifle before. For it was too late. The exercise measured not just technical performance, but also how quickly junior leaders and operators could incorporate the systems into their battle rhythm. This wasn't limited to tech specialists and other people like that. Infantry scouts and support personnel all took part in handling the systems, offering critical user feedback. That feedback loop, being a soldier-driven adaptation, is what sets Flytrap apart from most top-down acquisition efforts. It's gear being shaped by the people who will actually depend on it. And since there's not a massive defense contract at stake, at least not yet, maybe the generals and industry representatives will actually listen to the troops testing their things. Before you can disable a drone, you need to know it is coming and be able to see it. The Army has been experimenting with multiple systems, but they didn't specifically name any for Flytrap 4.0. However, imagery from the exercise shows compact radar and optic systems deployed on tripods consistent with systems in this class. So we will discuss some of those. The Echo Shield system by EchoDNE was shown atop of Stryker at the exercise. This small array delivers full hemispheric coverage, which is just a fancy way of saying it scans 360 degrees, and that was to detect all threats, including small drones. The panels can also be employed individually, and at just about 35 pounds each could theoretically be carried by a squad depending on their ability to generate power. The Radar RPS-42 radar. Now part of Elbit Systems is a compact hemisphere radar system that fits on a tripod and provides 360-degree coverage. These can be found on the Marine Corps MATIS and LMATIS systems, and it tracks small UAS targets with low radar cross-sections detecting threats out to 5 kilometers depending on the drone profile. The whole system itself weighs in at just 105 kilograms. I say just because you gotta remember, this is a full-fledged radar and that's about 230 pounds. So while it may not be practical for a fire team to carry one on patrol with the 5-kilometer or a 3.1-mile range, they can push out a little way and still have eyes on the sky, electro-optical and infrared, or EO/IR sensors like the Teledyne FLIR HRC system are used for day and night visual tracking and confirmation against the sky. A lot of these small drones are just invisible to the naked eye, but these systems can see both the electromagnetic and the heat signatures of anything coming at them. If those fail to see them, you might be able to hear them coming, so they're testing acoustic sensors for passive listening. When radio or GPS denial is in effect, Ukraine has developed and employed a system called Sky Fortress, which has networked listening stations dotted all over that cost under $1,000 each, and they can listen for drones, missiles, and other threats. They then relay this information to Anton gunners, who then ambush the targets. The US has had its eye on this specific system for a while now. But in Flytrap, they put to the test what they call Skyview using the square head acoustic panel. These passive detectors can be easily concealed, are relatively lightweight, and as we said already, they're passive, so they're harder to detect. Like the RPS-42 radar system that we just mentioned, Skyview can also be found on the MATIS. Information from these systems and more systems like them feed into a central software interface. And while the Android Tactical Assault Kit or ATEC wasn't officially named, it is the Army Standard C2, and that's command and control tool used across dismounted and small unit formations and is likely the framework used to display the threat map and direct engagements using the information from all these systems that they're testing. One system that was shown being used is the Night Fighter S built by Steel Rock Technologies. This is a man-portable tool that weighs about 37 pounds and works by disrupting the control signals, both in 2.4 and 5.8 GHz bands, as well as the navigation system, forcing the drones to return home and potentially betray their operator's location or just simply crash. This has a range of up to 2 kilometers, but currently it only runs for a little over an hour off the battery, which is an obvious limitation, one that can't easily be overcome with more batteries. But as we've discussed multiple times, soldiers have a ton of batteries and those get pretty heavy. U.S. troops have also been seen with several rifle-like jammers, including the drone gun. Both the tactical and Mark IV variants from Drone Shield, as well as the Drone Buster and the Drone Defender, just to name a few. There's more, but these are the big ones. These are shoulder-fire devices that jam GPS and control signals within a few hundred meters like the Night Fighter. These can trigger drone fail-safe modes like return to home or just straight crashes. Soldiers were also spotted wearing both the Wingman drone detector and the Pitbull personal drone jammers, which work together. These radio-looking devices do just as they say. The Wingman detects the drones and the Pitbull jams them without all the bulk. This sort of wearable and lightweight technology will be vital as formations return to more dispersed operations, much like how it was in the global war on terror when IEDs were ripping people apart. Troops are having to spread themselves out more to limit damage from hits, having to disperse more widely. Obviously put soldiers and others like Marines and airmen, sailors, whatever, Space Force, Guardians, I don't know, and kind of compromising sitting duck positions where they're 20-30 meters away from somebody else. This, as we've seen in Ukraine, is usually a very juicy target for an FPV drone operator. So these little jammers give those lone soldiers that are out there just trying to hide in the brush a fighting chance to detect and jam these drones. Just simply having the jammers, though, is not enough. And so soldiers also trained on when to use them and when not to. Jamming, as you can probably guess, is mostly a two-way street, and you can interfere with friendly signals. So coordination is key. If jamming fails or if it is a fiber optic drone that's impervious to jamming, you need to shoot it down. And that is easier said than done, but it is a vital capability that our troops just have to have. At Fly Trap, soldiers were seen with rifles outfitted with the Smash 2000 Smart Optic, which has been tested going back to 2020 and beyond, and in 2024, it was chosen by the Marine Corps as a way to defeat small drones. As we've said, hitting a small drone at any sort of a distance with a rifle isn't easy, but this increases the odds of a hit greatly. They also tested shotguns as a defense of last resort because yes, shotguns can take out drones that are close, but if you don't take them out far enough away, they can still potentially do damage. Number 9. Birdshot isn't quite cut out for this, and double-op buck doesn't give the spread you'd want. But rounds like the Skynet give you a better chance. Let's pray to God this works. Skynet defense. Now activated. These are just simple shotgun shells that fire a 5-foot wide net that can take a drone out up to 420 feet away. The Army has also been testing drones to intercept other drones. In one video posted recently by the 173rd Airborne Brigade Combat Team, a drone armed with a claymore, mine is unleashed on a target drone, shooting it down. As we have seen in Ukraine and now elsewhere, drones are increasingly being used for interception, whether as hit-to-kill vehicles or by carrying shotguns or other form of offensive measures, and now Ukraine is packing them with lots of shotguns. Each of these methods has trade-offs, and yes, the soldiers on the ground will have to make these decisions with those variables very rapidly. So in Fly Trap, they trained with decision-making under time pressure, which system to use, when to use them, and all those other variables based on drone type proximity. And of course, everyone's friend. Rules of engagement.